Welcome back. The most important part over here is that we should start with normal KK. I hope you recollect that in case of normal KK, this is the residual of residual data, and residual should be on the diagonal line, so that it is the really normal. But if you look like, if you see, there are some points which are deviating from the diagonal line, and it has given the number as well. Observation number 283, 275, 231, and it has also given this residual with fitted data. So these three is again over here deviating, and similarly over here. So what it is trying to say that if you try to fit this model again after removing these three, then probably you will get a bit better model. So this we can take it as a classwork. Intertrain, remove these three records and fit it again. And observe this R square. So we had the R square around 82%. After removing these three, do you find any increase? And I'm confident there will be increase in the R square. Okay. This is what the meaning of this one. Now, going back to this one. Now we are predicting the test data which we had around 15%. So 9148 to predict the test. So there are two kinds of error for regression. One is MAE, and MAE means mean absolute error, and the second is called RMSE, root mean square error. So for the this is the industry standard error that is for regression, and already there are a lot of the formula and multiple library implements. So we are using the model matrix library to calculate. It is taking the predicted and the actual. So 151 we are calculating MAE, 152 we are calculating RMSE, 153 we are printing it. So this is the sign it gives that this is the way we keep on comparing our various models. As of now 2.51 and 3.36. So how do we read it? How do we read it? Let me also print the mean of this one. Let me print marker. So how to read this? The mean is approximately 23. MA says that that when you do the prediction, on an average around 2.5, 2.5 is near to around 9% or around 10%. You may get error of around 9 to 10%, but on the maximum side, 3.36. So 3.36 is around how much it become around 14 to 15%. So we take the full figure. So we are saying on an average you will get error of around 10% and maximum error it may come to 15%. Is this okay as per the business point of view? If yes, then you are good to go. Else we have to improve the model. Okay, that is what. Now here we have done the prediction on the test and similarly do the prediction on the train itself. The train data it has already seen and calculate the error, this MAE, RMSE, and also see the mean and try to interpret and definitely you will find something different. I'm not explaining right now, but write your interpretation into the discussion board, and there I will help you that why you are getting that kind of error. Okay. That's good. Now let us go and draw the actual and prediction using this line. So this is the one utility functions I have written in the common utility that takes the actual and the prediction and draw it. So this will be done in the library ggplot. We are running 152 to 154 in one go, and yes, we take time. So okay, good, looking good, looking good. But actually, if you see, It's not that good, not that good, but it's okay. Not that good. But now we can detach it. And residual plot. Before we go ahead and do the residual plot, let us clear up the folder image folder. And but at least I'm selecting all, deleting all. This image folder is clean now. So residual plot, it is taking the actual predicted place to save and simply algorithm is so that it can be referenced. So I'm running the line 168 and it has started running. It is saved as well. So let us start with what it has done it. This is the GPU plot. So it's okay, only there are few deviations. And this is the one of the things you should look at. The graph of residual should be normal. It is normal, but not there is a perfect normal. Residual has the few of the outliers. It means there are few big or two small outliers. We should really worry about this outlier, but the residual is quite huge. And all rest look good. Okay, I'll request you that please look at each of these graphs and try to understand yourself. If you don't understand, I'll explain. Otherwise, let me explain itself for the first time. And this is the residual with observation sequence. And as per residual analysis, it should not have any pattern. But if you look like for here, there is a very thin residual, and over here it's okay, but here it has gone quite high. Here, gone quite high. And this is the residual with the predicted data. It is there is some pattern. That is what if there is any pattern, it's not good. Residual with actual, again there is some pattern, so it's not good. Now this is for actual, and this is actual is in the green, and the predicted one is in the red. So yes, you'll find some difference. Ideally, you should have seen only one of these lines that would have been on top of it. That would have been the perfect, but yes, the life is not perfect. Okay, that's all for the residual analysis, and that's all for the linear regression. Thanks for watching it. See you in the next one.